Have you ever mixed sugar in a tea or salt in water? Congratulations, you have just made a chemical solution. But what really happens when something dissolves? That's the question. Welcome to the fascinating world of solutions, a fundamental concept that explains everything from ocean salinity to blood chemistry. So let's see what is solution. A solution is a homogeneous mixture that means its composition is uniform throughout. It consists of a solute, which is the substance being dissolved, and a solvent, the medium doing the dissolving. For example, in salt water, salt is the solute and water is the solvent. Let's see types of solutions. Solutions come in all forms, solid, liquid, and gas. A solid solutions, that's what metal alloys like brass are. A liquid solution, think of lemonade or sugar in a tea. A gaseous solution, that's the air we breathe, a mix of gases like nitrogen and oxygen. Measuring instruments show molarity and molality, etc. Chemists love to measure things, and when it comes to solutions, they talk about concentration, how much solute is in a given amount of solvent. The most common units are molarity, moles per liter of solution, molality, moles per kilogram of solvent. Mole fraction, mass percent, and volume percent are also used depending on the context. Now let's see temperature versus solubility graphs. Graph pressure versus gas solubility. Solubility is how much solute can dissolve in a solvent at a specific temperature. It depends on the nature of the solute and solvent. The temperature solids dissolve better at higher temperature, but gases dissolve less. The pressure, especially for gases, higher pressure increases solubility in liquids, like in soda cans. Now let's see Henry's and Raoult's law. Henry's law says that amount of gas dissolved in liquid is proportional to its pressure above the surface. That's why soda fizzes when opened. On the other hand, Raoult's law deals with vapor pressure. It tells us how adding a solute lowers the vapor pressure of a solvent. This law is key to understanding boiling and freezing point changes. Next, we will see about colligative properties. Now comes the fun part. These are properties that depend only on the number of solute particles, not their identity. There are four: lowering of vapor pressure, boiling point elevation, freezing point depression, osmotic pressure. That's why salt is added to icy roads in winter. It lowers the freezing point of water. Or why antifreeze is used in car engines. It alters boiling and freezing points. Ideal versus non-ideal solutions. Ideal solutions follow Raoult's law exactly and mix without energy change. Non-ideal solutions deviate. They might release or absorb heat on mixing and show stronger or weaker intermolecular interactions. Most real-life solutions are non-ideal. Solutions are more than just things that dissolve. They are the chemical foundations of life. From medicines to drinks, from oceans to your own blood, solutions make up the world around us. Understanding how they behave helps scientists design drugs, treat diseases, and even store energy. So, next time you stir sugar in your tea, remember you are performing chemistry in action. Thank you.